previous video, we started dealing with checks, how to see and to verify if our king is in check and prevent the movements that bring our king in check or don't block the check that our king currently has. We start dealing with the function here, check valid move, created some other functions to help us out, and we stopped here, comment this out, because we said we would have a infinite loop if we had this, because one function be calling the other and the other and the other, so our code will never finish. Technically, what we need to do here to prevent this infinite loop is to have our is in check only be verified in the first round, in the first time that we execute this function, the checked valid move, not for when we are checking the moves of the opposite player, for the opponent. So it would be as simple as verifying like should verify check, like so. And now this would become then another, even another here, parameter, which would be by default false, not true. And then we can send this from our function here. So get valid moves would send this here. Oh, sorry, one miss here. Would send a false here. And in the get valid moves down here, would receive it, send to the piece. The piece would need to send here, and so on, so on, so on. You see that we are passing this information over and over and over, and that's not good. We're just repeating and sending one parameter across multiple functions to use it in just one. Kind of, if you think about React, kind of the props drilling. We are sending everything down, like a lot of layers down in the hierarchy, just to use in the end. And as you see in React, props drilling, that's not good, so we want to avoid that. And to avoid this, all of this, what we need to do is to refactor and reorganizing our code. And for that, it's time to use our game model, which as of now is still empty. Just like our board model, let me bring it here. This will be a class, and the game model will have a board. So let's create this first, export default here, game model, and we'll have, as I mentioned, a board. So the same idea here as a property, board, to be of board model. Like so, constructor, it will start a new board. So this board equals new board model, like so. What am I missing can be undefined. Simply expecting one argument, or let me send a no. I'm change this to no, like this. And in this game model, we can also have some information that we have in the app. Which informations are these? Player turn, who is currently playing. Movie history list, what is the history of the moves played in this game. Let's add this here then. Player turn, it will be player color. And we're going to have here then movie history, which will be an array of move history model. This will start this dot player turn, as you can imagine, just like before, in white, and this dot movie history is start as an empty array. Simple like that. No mystery here. And our app TX, instead of having a board, we're going to have a game. Let's rename this here, board to game, and call this then new game model. And this player turn and movie history list completely disappear because they are now part of the game. This whole structure that we have here need to be reorganized, of course, but we're going to extract this logic to the game model, and it will be much better because now our app.ts will become much simpler. And we extract the logic from the component, which is mostly to be able to show information, right? The presentation layer. And we bring this logic to our model. Okay, let's then come back here in the board. I'm just going to say game.board, game.moveHistoryList, movie history, not movie history list, just movie history, I think, and game.playerTurn. Here the same. We may need to reorganize this a bit later, like maybe send down the game completely instead of sending information bits by bits. But for now, just going to replace this like so. Now, all of this board move piece and the set movie history list and here update square piece are functions that can be called inside the game model. We just need to create them, of course. So I'm going to create here a new function. It will be then the move piece. This move piece return void. And just like the app, let me put this side by side to be easier. Have here the move piece. We have a current square, a final square, and the move itself. Let's bring this here. Current square, final square, and so on. Now, inside of this move piece, we're going to execute the code that we already had before, like so. Oh, I forgot the if. It's because we don't have the promotion coordinates. We're going to deal with that later on. So for now, let's comment this out. Put here set movie history list. Piece has moved. Board. Okay. And I'm going to also bring this here. Okay, the whole logic. And this now move piece, what we'll be doing? Game dot move piece. Current square, final square, and the move itself. Okay, first part extracted. This switch player turn can also come here. Let's have here, so switch player turn. Instead of set player turn, because it's not part of the state anymore, it's going to say please player turn equals what? Let me here player turn like so. So if it's current player color white, goes through black, otherwise goes to white. We put like this. Add all missing imports. See, there's still missing some. And the set movie history list instead of using the state like we're doing before. Now we can simply do a push. This movie history push. Push what? This. We put it here. Color this dot player turn. Need to update this. And now this dot board dot move piece. What else am I missing? Here there is a. Yeah, we need to also put this inside, right? Otherwise have some issues. And switch player turn. Just need to put this in front of it. Now, nice. Converting the logic from one place to the other, like extracting, making this presentation layer simpler, and bringing then the logic of our game to the game model. Going back to the app, let's see what we have here. We have this make rook castle move. Let's bring this to the game model, which could also be brought, to think of it, to the board. Like the board would be able to make this, right? Not the game model per se. But for now, let's have it here and see if we can transfer this to the board model later on. Here, add import for the piece model, this.board, like so. We completely remove that from here, remove this from here. Don't need this anymore, nor this, nor this. So clean up a lot. This app CSS we're probably going to delete because as of now it's completely empty. And now the set promotion piece, it's slightly different, right? So we have here this new state, and we're going to add here, do the switch player turn, all of that. We can bring then this to the game model as well. Add all missing imports, and the promotion coordinates needs to become part of here. So promotion coordinates become a coordinate model or no. So what we said before, I think if I'm not mistaken, yes, can be coordinate model or no. And this of course starts no. Remove this from here. And now game.promotion coordinates, game.promotion coordinates, select promotion piece. We also need to have this function here just to call the one game model. Let's go it here. const. This will be a void and receives a type piece type. The function will be game.select promotion piece type. Like so. Our app completely refactored and much, much simpler, while the logic now is brought to the game model. Here, you just need to add some this in front of a couple of stuff. This player turn, set promotion coordinates, no, just go directly. This promotion coordinates equals no. Set movie history list to be slightly different, right? I'm going to comment this out because now we need to replace the last one. And here this dot switch player turn. Here we can now uncomment this part because we have the promotion coordinates. And this looks good. This looks good. This I'm still not uncommenting because of our logic that we're still dealing with it. If I'm not mistaken, it is here in the board model. So it's part of the move piece. Let's check it out how these will work together with one another. For now, I'm letting it commented out. However, the set movie history list we can already deal with. We don't need this part of the state. We just need to get the move history to fetch the last one. So we just replace here the current value, like so. And this return actually is the set of this.move history. Placing here current, slice, and last move, like that. This looks good to me. Apt, yes, no problems. Move, let me remove this should verify check here. Or no, this can let, but yeah, this needs to be commented out. Perfect. And now I can start our application. See if there's any errors. Refresh, just the 5 icon. That's good. And I should be still able to move our pieces and play the game normally. However, we didn't switch the player. So let's go back to our game model and understand what is going on, because the switch player turn didn't actually update here in our presentation layer. And I'm pretty sure this is happening because game model is an object here, okay, in our state. But whenever we switch the player turn here inside the object, the state is not updated because the state uses a reference to guarantee that something changes, to check if something changes, not the values inside of it. So what we can do here is to create a new state, const, and say just key, and set key, which will start, I'm going to use here a simple number, so starting 0. And now the key will be the key of our div. So, and every time we move a piece, we're going to say current key +1. Come back to our application, go to refresh, and now if I switch, everything works as expected. Because this dummy key here is forcing our React component to re-render every time this happens. If there's other functions that we also need to force a re-render, this is a simple way of ensuring it, because we know stuff changed, but React didn't. So we just give him a little push saying, let's go, update here, and we can move on. With that out of the way, we can move on replacing the logic of our move service and other stuff into the game model and maybe the board model to free up all of these unnecessary parameters that we're sending all around. Okay, for example, this down here, we have this last move. Supposing that this get valid moves function here is inside the game model, do we need all of this? We don't, right? We only need to square. Okay, which square do I want to check the valid moves for? So let's bring this up there. Game model. We have here get valid moves. We don't need the board, and we don't need the last move, because this is already part of our game model. So here, okay, we receive the square, everything perfect, and the board, we're going to say this board, and let's move. We can even create a function, get last move. Let me create it here. Get last move. It will return a move history model or undefined. Maybe no. Let's check it out. And we are going to shift this here, return this. If this dot move history dot length, so if it does not, I'm going to return undefined or no. Let's return no. Undefined. Because then here's also returning undefined and then allows me to not return undefined and no all around. Then we just change this, get let's move. Maybe can even, yeah, let's leave it like this. So I'm going to say this. Actually, no, I need to put this inside an if. It's a bit stupid, but I need to do it. Because now it can return also. And there, perfect. That's fine. And in the last one here, this dot gets let's move. Our get valid moves is inside the piece model. Receives here a move history model or no. Let's change this to undefined. And we also use this in the pawn piece model, if I'm not mistaken. So yeah, here. Undefined. Perfect. Let me close this, let me close this. And we change this slightly already from the move service. So this get valid moves from the move service into the game model. But where are we using the get valid moves? Let's search it out. The board here. Everything else it's inside of its other functions. As you see, get valid moves go from row and column and so on. But we want looking for our board. It's the only presentation layer that uses this get valid moves. And here it uses the move history list. It uses the board, which is itself, in the selected square. So technically, if we had the game model here, we could say return game. No, we don't have it here. Okay, I know, but we're going to get there. Game.get valid moves, and then selected square, which would allow us to remove the move history list completely from here, and also the board, because we only want here the selected square is the only thing that would change between the get valid moves, which makes a lot of sense if you stop to think of it. We don't need to verify the valid moves, like if it's the move history list changed. That doesn't make much sense. So now we can remove all of this. Thank you, Lint, for breaking everything apart. Which means that we can also remove the movie history list from the props, cleaning up a bit our board TCX. And here in the app, we can break this down. Okay, nice. That's another improvement, but we need to somehow get the game to be able to get the valid moves. Selected square. How do we do that? We can send down the game. Instead of sending out the board, the player turn, and all of this, like no, this one it's different, we can send the game itself. Does it make sense to be sending down the game to the board? Debatable. Debatable. But for now, we're going to do it. And later on, if we change our minds, we can refactor this a bit and pass down other information. Okay, so game to be type of game model can replace this, can remove this and this. It's getting better and better. Cleaner and cleaner, our components. Have here the game. And now this is not select square, is selected square, like so. Remove this. Simply, we also need a game, of course. The rest should stay kind of the same. Now here, player turn, game dot player turn. Anything else that I'm missing? I think not. Let me see, board. No. Here, yes. Game dot board dot squares. Okay, that looks good in the app. We don't send the board now anymore. We send the game in full. don't send the player turn because this is already inside the game. And now we have playing as white, move pieces, put this up just to have the functions in the last part. Bit more of refactor. It's getting better and better, as I mentioned. Let's refresh here. Cannot read pawn. Yeah, this is some recursive problems. We're starting the board before having the game model. Okay, I see what's going on. Let me close everything and open the initial piece positions. Why does this error happen? This happens because we have a cycle in our imports. So the initial piece positions being imported within the piece type is being imported, importing something else, and so on. And then at some point, we have a loop in our imports, and that's why this error is going on. We need to find out then the initial piece positions is imported by our board model, right? And is also imported by then our game model. And somehow then there's something here import that our game model imports, maybe the movie history model, which imports piece type or initial piece positions. And this is causing the loop. We just need to find the loop, and then this will be easy to fix. Of course, that's easier said than done, but let's start and go to our initial piece positions and check out the imports that we have here. We have player color coming from player model. I highly doubt this is an issue. So most likely the problem is coming from piece type, as we can imagine, right? So in the piece type, so piece info, we have here the imports of all of our bishop, piece model, king stuff. So let me open the bishop first. And it imports also the piece type, which comes from piece info, like here. So even if this may not be the problem of that's causing this right now, I'm going to change this a bit to get this enum out of here. And then all of this bishop piece model, king piece model, and everything can import the piece type without worrying about being re-imported. Yeah. Okay. So there is a small issue here. Let's get these models. We have piece model. I'm going to say a piece type here. So piece type, not model, because it's not a model per se, is it? No. Let's just grab it here, enum piece type, and say piece type model, but it's an enum, so I will not rename it like so. And now here we can import this piece type. Add import. Bring this up just to be slightly more organized. And everywhere that the piece type was being imported now broke, of course. Let's rename. Let's get that fixed. Piece type. Suppose that we're going to go for all of these ones. The knight, remove, re-import. I didn't do the king, so remove, re-import, the pawn, remove, re-import, the queen, remove, re-import, rook, remove, and re-import. Okay, these ones slightly fixed, but I'm pretty sure that the piece type is being used in other places as well. So let's add this. There's more sport, piece type, not from here. Import. Okay, that's better. And initial piece positions, of course, it's not coming from here anymore. Now it's coming from the new file. I'll close everything again, open just the initial piece positions, refresh our page. See that, okay, we still have in the move service a small problem with the imports. Let's go there and fix it. Move this. Piece type king here. Okay, add this. The last move. Here it's no, and now I'm accepting undefined, so let me change this to undefined as well. Although this is not being used anymore, so just to not break. Refresh here. Bishop still has a small problem with the bishop. Let me check it out. Maybe I didn't update the bishop. Okay, thought I had. Maybe I didn't. Refresh, and now, yeah, that was exactly the problem. And we are back. Game's on. Let me close everything here, and I'm fine with that. It was easier than expected. Continue for our refactor. Let me open here the move service and our game model. This move service actually now can be slightly renamed to a move validation service, because now it's the only thing it does. It's really to validate. And in the game model, now that I think of it, I don't want to repeat the code from this move validation service, and I don't want to bring this directly into the game model, because here we're always using the updated board, so the board that we're currently playing on. However, for these functions here, the get all valid moves for player is in check, we create a new board, as you see here. For that, we need to receive indeed the board as a parameter in order to keep this function without being attached to a specific board. So it keeps the function not necessarily pure, but it allows to receive different boards and make these calculations, not just on top of our game model. Okay? So what I'm going to do here is to return the get valid moves that are here from the move validation service, and send them this dot board, this square, and the this dot get last move, like so. Do I have this imported already? Let me comment all of this out. Not needed. Here since square can be null or undefined, square model or no, that is fine. Yeah, it's because it's not this dot get valid moves, it's just like get valid moves. It's my bad. And now we add the import. Okay, that's fine. This now will call this function here, but the code's not repeated and we can do everything from the game model. But now we kind of come back to point zero from the start of this video, even before all of this refactor, which is really good. Yes, we removed some of the logic from the app, brought to the game model, organized the files a bit better, renamed here, did a bit of a refactor and touched up in our files. But the problem persists. We still cannot make this call this function without causing an infinite loop in our application.